Alright, good evening everyone. Making this video concerning our last PCO practical for those of you in group A. I know most of you didn't understand it when the man, like the lecturer was explaining, including myself. So today I went to meet her and she emphasized on it properly for me, and I take out the student a bit. So I'm taking acetylcholine as a standard. Let's assume like this our various concentration of acetylcholine we used in our practicals, which are these ones here. So okay, and our aim is to get what the final concentration, the final back concentration, which is our final dose of what will be plotting, of what we'll be using to plot the graph. So she explained that the volume of the agar bath is 10 ml, which is what I wrote here. Here it is. And let's assume like this, let's assume this is the agar bath, which is 10, which with the volume of what of 10 ml. And I want to calculate what the concentration of what of the first acetylcholine, which is this. So she said that let's assume I took what 0.4 ml of what of acetylcholine. Just picture this concentration of acetylcholine as what as a salt solution of this of what of 0.01 microgram per ml, and you took what 0.4 ml from this word concentration, and what you dissolve it in what in the agar bath. Take it as, let's assume it is a salt solution. Now when you dissolve it in the agar bath, the concentration will reduce while the volume of the agar bath will increase. Yeah. So using our normal C1 V1 or C inertial, which is what I did here. C inertial volume inertial equals to what? C1 V1. My C1 is what is 0.001 microgram per ml, which is this from calculating for the concentration of what of the first one. Well, and my V1 is what 0.04. So I'm looking for my C1. I don't know it. My V1 is given, which is now what is no longer 10. It's no longer 10 ml. It's now what 10.4 because you took 0.4. They added it here. Give a final volume of what 10.4. So I've gotten the final volume. So I want to calculate the final concentration of the draws in this agar bath, which is what I don't know. So using our normal equation, I'll be C, like in this case C inertial volume inertial equals to C1 V1. So after the mathematical this expression, I got my C1 to be 0.0085 microgram per ml, which is what I did here. So the same procedure is applied to get C2. How did I do it? Same me. I using what I took assume. This is my C2. I want to calculate for C2. This one, the next concentration is this. So in this case, my concentration will now be 0.1 microgram per ml, and the volume was the same. I took from this stock solution. I took 0.4 ml of what from this 0.1 microgram per ml, and as the same procedure, I dissolve it in this agar bath. For volume of the volume of C2 is not 10.4. We have 10.4 in it already. Then I added another 0.4 into it. So the volume now be what 10.8 ml, no longer 10.4. So using my same formula, this is my 0.1, which is this concentration here. My volume is the same, it's constant, which is this. It's 0.4. Then I'm looking for my C2, which is this here, and then I don't know. I know my V2, which is 10.8. So this is it here. Then after calculation, I arrive at this. The same procedure will be the same procedure for C3. In this case, my C3, this now my concentration, this now my C inertial, this is my volume inertial. I'm looking for C3, I don't know it. So in this case, my volume for C3, the volume I will use to calculate C3 is no longer 10.8. Now will be 10.8 plus 0.4, which is about 11.2. The same procedure will be done to calculate for C4, and I just dubbed C3 and C4, and I calculated for C5. You see the same formula: C inertial volume inertial equal to C5 V5. So in this case, this is what I'm looking. This is my now this will now be my concentration 10 microgram per ml for C5. Then the volume is constant. I took 0.4 again from this concentration, and I added it to the agar bath containing the other volume before, and I did it. So my final volume in the agar bath after adding 0.4 of this, I took 0.4 from this, will now be what? To be 12. Yeah, to be 12. Then use a normal formula to calculate this, to calculate for C5. Now make it, if I show the formula, I have a 3.335 microgram per ml. That is it. Okay, she also said that if the method she explained is difficult for us to understand, she said we should stick to what we learned, like what we were taught in the previous practical, which in this case, this is my manual from my previous practical. Yeah, how did I got this? How did I got 0.2? I used 0.2 me of this, that you just multiply this by this to have this. But he said in this case, we are assuming toward this one that reduce the concentration of the drug in the organ bag, which is not supposed to be so. So this one method, she said it is not the standard method. It's supposed to be 0.2 me of what of these drugs, silicone in this case, plus the volume in the organ bag that's supposed to reduce the concentration of the organ of the drugs, not just this alone. So he said the other one is too difficult for you to do, so like we should stick to this one. But for step down and for examination's sake, he said the method she taught us is the standard. So when you know that it's convenient for you to use, know the way you understood better, you just make use of it. But for exam's sake and research purpose, this is the right method that is like adopted. All right, now to the response. How do I get response? It's very, very simple. So this was the stuff we did. Yeah, this is it for acetylcholine. So to get response, all you need to do, you take a ruler, you measure from the base. In this case, this is my base, and this is my first response on the administration of the first concentration. This was my response. So you just get your ruler, start from 0, and measure to the base. When I measured mine, I think I got 0.6 for my first. Yeah, I got 0.6 for my first. No, for my first measurement. And after I measured the next one, I did write that one down, and I measured the maximum response I got was 1.6. So to calculate response, to get response, just measure it. Then from that response, you get percentage response, which I did include in this table. So you can just, before you write percentage response, you can just leave a space, write a response, then percentage response. To get percentage response is very simple. But this is the formula here. Percentage response is equals to a response over maximum response times 100%. In my from what I measured for acetylcholine, I'm talking about acetylcholine, I got my maximum for the first one I got 0.6 cm, and my maximum response was 1.6. There it is. There is my maximum response. Started from the base, and I got 1.6. Hey, that is all. And how the graph looks like. This is how the graph looks like. So you plot your percentage response against your log dose for acetylcholine. Yeah, you plot it. So how do I get my how do I get the log of those? Is very simple. It is from this place you look for it, from this final batch concentration. All you need to do, just place this value on your calculator. Then you have this. Then for the same thing for C2, how do I get it? Plot this value on your calculator. You have this. Then so C3, what you got here, just put on your calculator down to 6.5. Put on your calculator, you have your log dose. Then you plot your percentage response. This is percentage response against log of dose. Like this. And this one, everything I explain it just for acetylcholine alone. You do the same thing for oxytocin. I've not done that. You just do the same thing for oxytocin, and then follow the same procedure. Calculate for oxytocin. So anything you don't understand, just like message me. I will be away from now till 12 o'clock. I'll be away. So just message me if you don't really grab it. Thank you.